Hello everyone and welcome to Dr. Data Science for April, and we have Stephen, our Director of Data Science with us. So as always, we do this Dr. Data Science every third Wednesday at 9 a.m. Pacific, or if you're in Eastern, 12 p.m. Eastern. And we release the recording of our sessions on YouTube as soon as we can. But I'm going to share the Dr. Data Science playlist link on the chat shortly. If you have any questions about the session, please don't hesitate to put those questions in Q&A section of the Zoom. So it's easier to monitor and answer those in there. Stephen, over to you.
Thanks, Dinad. Hey, everybody. It's good to be back. Looking forward to today's session. I hope everybody is healthy and sane. I'm sure this is just one of many Zoom meetings you're attending this week. Let's get down to it because we've got a lot to cover today. We've got a special guest again, as usual. Dr. Data Science really represents the sort of the communal wisdom of the data science team at TIBCO, and one of the data scientists is Thomas Jurczyk, and he's here to talk about our featured session. We'll get to that in a second. Last month, if you remember, we did our usual information gain session, just a little snippet of useful information about data science. And we talked about what happens when you have sort of rare events and you're trying to build a classification model. And our featured session there was part of a two-parter. We had covered how to handle adding structure to text data. And then last month we covered adding structure to image data, which I think was really interesting. This month, we're gonna do an information gain on, well, I was thinking, as I always do for these sessions, what questions do people ask most? Especially when I'm sort of working with data scientists who are a little newer, or maybe I'm interviewing people and they ask me questions. I've tried to include a few of those in previous sessions in these information gains, and those have been technical. But then I was thinking this week, one of the most common questions I'm asked is, how can I actually become a data scientist, especially for people who are sort of coming out of school or maybe thinking about switching careers. So that's what we're going to cover in our information gain session, just spend a few minutes on that. And then our featured session, as I mentioned with Tomasz, is going to be, we called it best in class, and how do you find the best classification model using tools like gains charts, ROC curves, confusion matrices, and so on. So that's what we're doing today. All right, so today's info gain session, how can I become a data scientist? So again, it's a little bit of a departure for us. We usually cover a technical topic, but I thought it might be fun to answer as I say, what's one of the most common questions I've been asked. And I've tried to boil it down, and I was thinking, what do I really advise sort of new graduates or friends who are trying to switch careers? And this is what I'll typically say. You really want to have a thorough grounding. First of all, there's no royal road to data science, right? There's no easy way to get there. You can't just take a single online course and hope that that'll qualify you for a job. So I think you really do need a grounding in statistics, probability distribution functions and statistical tests, Bayes rule, and all that sort of basic stuff that you need to have in the back of your head when you're doing data science. And there are online courses, but I really think you need sort of a college level course. It doesn't mean you can't take it online, of course. There are lots of sort of extension classes you can take from accredited universities, but I think that's sort of the level you need a thorough grounding there. Then I would say you can absolutely get a pretty good sense of the sort of basic techniques of machine learning and data science from online courses and MOOCs. The classic one is Andrew Ng's course from Stanford. Professor Ng was one of the founding lecturers at Coursera. I think it's still one of the most popular courses there. I haven't looked at it in a long time, but I think they still offer it. But, a sort of a well-produced, reputable source like Coursera producing a machine learning online course from a recognized authority. I think you can absolutely learn a lot from that. And then in terms of sort of the technical skills you need, well, historically the primary languages in data science have been R and Python. I think these days Python is is becoming dominant. And I really would recommend that. R is still very powerful and useful. It doesn't seem to be going anywhere, but Python just increases in popularity month by month. And as a result of that, you sort of have this cumulative effect where the more people are using it, the more libraries and extensions and integrations they create, which makes it more popular and so on. So you have this virtuous circle. So I really think Python is where it's at. But I wouldn't underemphasize the importance of SQL as well. SQL is still the most popular programming language in the world. It's reflected, as you see in this chart, as being on more job postings than any other language. And it really is a core part of a data scientist's skills. You are, whether you're working with big data systems or traditional databases, SQL is primarily the interface for working with those. So I think SQL is still very powerful and useful for data prep and ETL type work. So once you've got those sort of core skills, then you just want to do some data science. I think especially if you're trying to switch careers or get your first job, it's very difficult. You have this sort of chicken and egg problem. They want you to have experience, but you don't have experience until you've got a job. And one way to get around that is just to work on your own data science project. Just find some interesting data, find a topic that's interesting to you and ask questions about that. Lots of people these days doing research into COVID-19, of course, and there are lots of interesting data sets around that. And you can look at it in terms of your locality and do something that's maybe a little different from what other people are doing. But I've been thinking about other projects that we've done here at TIBCO Data Science with some of our interns. You'll remember that Adam Faskvitz gave one of the data science talks about using various methods as a means of finding outliers when looking at baseball seasons. So we looked at seasons of baseball over the last 100 years, and we used various time series encoding methods to find outliers. And Adam was really passionate about sports, about baseball in particular. And so I gave him the sort of freedom to work on a data science project that was motivated by his interests. And so he picked the data from these baseball seasons and came up with some interesting questions around those. And another project we worked on for Tipping Point in San Francisco, a charity there, was around children who dropped out of foster care. And we gave that to one of our newer data scientists and just came up with some interesting insights about that. So just find some of these data sets or write to not-for-profits and offer your skills, your newly acquired skills, as a way of really learning how to do data science in the real world. Anyway, so those are some pointers I would have to becoming a data scientist. And now let's switch over to the core session with Tomasz. So welcome, Tomasz. Thanks for joining us.
Thank you, Stephen. So let me share my screen.
So you're going to talk to us a little bit about gains and ROC curves. I think, for a lot of us, we feel like we already know them. And yet, if you ever asked us what exactly is an ROC curve, we might have to scratch our heads a little bit. So go ahead and tell us a little bit about how these things are best used and sort of caveats around them and how they're used in practice.
Yeah, exactly. So it was also my motivation for going into this and investigating these, because they are nice diagnostic tools, but they are not easy to understand, and you can easily forget how they are constructed if you are not use them often. So
I have to look it up every time. Every time I use an ROC curve, I have to remind myself what exactly it is.
Exactly. So I hope that this session will be useful for anybody who, at least at some point, asking the questions like, what is ROC curve? How to read it? How can I find out the best model, or how can I find that the model is good? Or let's say simply, okay, I have all these measures, so what is the difference between these? And so on. So that's the questions you can have, right? And I think that's interesting to show it.
Yeah, I think a lot of people sort of have their favorite go-to metric or chart, right? And I think it's useful to think, well, are there others I should be using, and exactly like what is the difference between them, and when is it useful to use one versus the other?
Yeah, exactly. So hopefully you will have answers to these questions after this call. So okay, so let me start with something like general. So if we are data scientists, we are typically doing through the whole process of modeling. At the beginning, of course, we need to load the data, merge them, prepare them, clean them, then separate into training and testing data, then choose, I don't know, important variables to not use all the variables which are at hand. Then try a lot of models with different settings. That's when fun begins. And then of course you need to decide when you have all these models and all these results, what is the best model, and that's of course the main thing of our presentation here. So let me jump, and of course once you have the best model and you are satisfied and business is satisfied, you can deploy it in the production.
And I guess the question there is, what is the best, right?
Yeah, exactly. So let me show it on example. So we have here typical data science tool, and let's say each icon is some functionality, and we are starting with the data. So in this example, we have a data from loans. So each row is an applicant for a loan, and it's a historical data. So we have already information if this client was good or bad, and then we have some other information like about the loan itself or about the applicants, like if it is or she is single or and so forth. And our task, of course, when we have this nice historical data set, is to try to predict this category based on all of these things which we know at the beginning, which we know at the time when the applicants want a loan, right? So that's our task, and it's classification task because we want to have classification, good or bad. Then we are splitting the data into two parts, training and testing. And on this training data, we might do, I don't know, like feature selection, choosing which variables are most important for distinguishing these two categories. Then we are trying a lot of, or several methods, and they are producing some models. And once we have these models, we are applying these models on our testing data. And this is important because it's somehow not introducing the bias because we are using data which were not used for training. So let's say our results can be much cleaner. And this a node over there is simply applying these models on this testing data. So what it is doing, these models are calculating the probabilities. So for each model, let's say for card tree, I have probability of being, for each row is again the applicant, I have probability of being good, being bad, or being good. And for this is for each method. So this is, let's say, our predictions, but also this tool is bringing a lot of analytics which I can use for my decisioning. So for example, here I can see cumulative gains chart, and we will be talking about that later. But simply you can see that for each model there is some line, and simply speaking, what is the highest is the better one or best one. So let's say the green one here. But we have also other charts like lift chart here. So again, we can see the green one, which is random forest, is good, and the poor one is here, which is like card trees, which is maybe expectable. And then we have other ones like ROC curve or confusion matrix for each model and so on. But going back to slides. So the software is throwing at us a lot of these diagnostic plots, and we will try our diagnostic tools, and we are deciding according to that. So let us dig a bit deeper what they are. So the main thing what the model is producing are these probabilities. So we have probabilities of categories, in our case good and bad, and of course we have some historical information because we have historical data, if really what was really the response, if the client was good or if the client was not good. And let us first sort these probabilities. So we can sort according to probability of event category, which is bad in our case. So I will sort it based on this, and I will start computing points on the diagnostic curves based on some scenarios. So let's say the first scenario would be take 10% of the points according to this most probable of being bad category. So at 10%, we will say, okay, the prediction is bad, and here the prediction is good. So simply, I don't know if you have like different use case, like if you have, for example, fraud investigation, and you want to investigate 10% of your cases. So how you will do it? Simply, you will look at your predictions, and these which has the highest probability of being bad will be predicted as bad. That's this scenario.
So let me make sure I understood that. So you're saying
Sure.
part of the way we compute these charts is to pick a point, pick a cutoff point, like saying the 10% most likely to be bad. And you've drawn that cutoff there. It just happens to be on the boundary between the bad and the good there, right? Is that a coincidence, or like could you have picked it higher up? I guess that's how you're defining the difference between
Yeah,
bad.
exactly. So this is a percentile. So this is let's say I choose 10%, and that's my prediction of this particular situation, this particular scenario. But to have all the charts, you will need different thresholds, different cutoff points.
Got it.
So maybe it will be clear from this picture. So I take 10%, and I will start with gains chart because let's say it's simply understandable. So on x-axis of this gains chart, I have exactly like how many points were predicted as bad, which is 10%, right? It's this x, and on the y-axis I have something like percentage of correctly spotted events out of all events in the data set. So I have something like 28, which means if I have, for example, in my data 100 bad applicants, then with in this thing over there, in these 10% will be 28 cases of these. So it's how this chart is how this concrete point is constructed. Maybe it's good to describe what is this blue line. The blue line is, let's say, the model which is completely random. So it's like comparison, or it's in this chart because it's comparison to our model, which is here the red one. But this one is random model, and this means simply you will take 10% of data randomly or clients or cases, and you will flip a coin, and if it's good, it will be one side of the coin, it's bad other side. And so generally you will have something around, in 10% you will have something around 10% of spotted cases, but I have 29, so I'm better. And
so that's kind of, I guess, why it's called gains, right? You're saying, so if you just picked 10 at random, then you're like 10 out of 100 or 10%, then you're likely to get about 10% of the actual bad events. But with your model, you got 28 or so, so you've gained over that 10%.
Exactly.
Cool.
And this one, this green one is like what I can do the best. So the closer I am to this green line, this is like theoretical optimal model, but of course in practice very hard to get, but or impossible. But simply the closer I'm with this curve to this green one, I have a better model.
Got it.
And I can do the same thing for different percentiles. So if I have now 20% cutoff, it's not the whole table, it's longer, but it's not visible there. So I can plot all these points, and I will have this nice chart. So that's the basic of gains chart, and it's not that hard to understand it.
Cool, great.
For lift chart, this is even when you know what is gains chart, lift chart is even simpler because it's constructed from gains chart, and it's some kind of like how much, it's a measure how much better is the predictive model than a random model. So you are constructing it in the way you will take this gain value from here and divide it by this one, and you will have this point. And this one divided by this one.
I guess, right? Because 28 was 2.8 better than the 10% you got at random.
Yeah. So that's the lift chart, and in fact that's my preference because you immediately see how much better it is. So the x-axis is the same, is the percentile, and this is this ratio of your model and the baseline model. So very easy.
I'm guessing that label maybe comes from the marketing world, right? Because there they talk about the lift that a model gives you.
Yeah, benefit lift, something like this. I don't know, but simply it's how much is better, what benefit or lift it is bringing. So makes sense.
Okay, I'm with you so far.
Yeah, so here I have confusion metrics. This is a bit different principle because we don't have charts, but confusion matrix is in fact some snapshot of a classification for concrete cutoff value. So if I decide some cutoff value and create a rule for classifying, like probability of event is larger than cutoff, then I can count how many times I was correct in my classification, how many times I was not correct. So let's say if I have event yes, no, then I can construct something like this. And if I'm predicting yes, and how many times I'm correct. So that's true positive, and it's calculated like a count here. This one is also I'm correct. I'm predicting no, and in fact I'm no, or in our case it was good category, and these two are the wrong ones. So if I translate it into these bars, which are maybe more visually understandable, yes, yes, predicted, observed. So if I am on this diagonal, I want to have these as high as possible, and these on the other diagonal smallest as possible. So that's my let's say this is my like check of the model, what is the check of the output of the model, if it's good or bad.
And the point here you were making, right, is that this is, I find confusion matrices really intuitive, right? It's sort of like how many of the ones I want to get from the bads and the goods am I actually getting, and how many am I missing? But as you say, you are picking just one cutoff point, unlike those charts where you're really surveying all the cutoff points along the x-axis there.
Yes, yes, because if I have this slide where I have the situation for this 10%, and it's in fact this confusion matrix. So you will be not satisfied with this one much, maybe because this is too small. But it's part of this chart, and in some scenario even this one could be good. It depends on your use case, but let's say it's only some snapshot of this line. So I like more to compare the models from these charts than from one confusion matrix. And also for different models you can be on different like, because this is growing with the threshold, like we have here 0.59, but for other model 0.59 could be here or here. It depends. So it's not like a general thing. You can decide if your model is good, but it's hard to decide based on confusion matrix which model is better.
Right.
And this is the relationship between the confusion matrix and gains. So it's simply each confusion matrix is 1 point on this chart, and if we are looking at the gains, it's, let's say 10% here is like probability of bet. So these two together are 10% out of all, and this axis is this one, like this is 28% of all these two together.
I really like this. This I think is a really good slide to sort of stare at. It makes it very clear the relationship between one and the other. And then as you have on the other slide, the lift is really just a alternative way of looking at gains.
Yep. Thanks. And the last one, but maybe the most popular one, is ROC curve. So it's also the same one. You are changing the cutoff point and drawing some computations from this confusion matrix, but in fact you are drawing a bit different things. So on x-axis is false positive rate, which is like this one divided by these two together, and on this axis you have true positive rate, which is this one divided by these two together. So and again I have this random model and I have a perfect model over there. So of course perfect one is when I have no errors, no false positives, right? So it's going there and there. So the closer you are to this corner with this chart, the better model it is. And if you compare it, I maybe like this slide even more. For when you compare it like ROC and the gains chart, it's this. So the blue, in fact, the y-axis is the same. It's called maybe differently because it's sensitivity, or, but this one is same, and it's taken this this one divided by these two together. But the x-axis, this one is for, let's say, these percentiles, like how many bets I'm taking, and this one is giving this false positive rate. So in fact, you have like these are constructed from the same information, but simply a bit different in a different way, or different y-axis. And I tried to create something even more interactive, like this one. So I have here the gains chart, the ROC curve. They have the same, let's say, y-axis, and that's a lift chart. And if I choose some threshold, or I can choose some threshold here, let's say 50% for probability, and this is the confusion matrix for this 0.5 probability, and it's this point on the charts, and I can try to play with that, and let's say see where it is, and that's, let's say, the complete look that, okay, we have these many charts and many tools, but in fact they are somehow connected all together, uh, with with these confusion matrices going through the different cutoffs.
That's great.
Okay, so
which one do you use in practice, Tomasz?
I'm using lift chart. It's very easy to explain, and yeah, I'm using lift chart, and also in some scenarios, like you cannot, for example, confusion matrix. For example, in this scenario, okay, you want to have really you want to pick, you want to find the fraud, but you have only some limited resources, like you can check only 10%. So in that case, I would be looking at the lift at 10%, and which model is the best. This I will choose, and also you can, when you have this overall picture of, okay, 10% is around probability 0.6. So you have also some guidance how to choose the probability, because how you will otherwise find out what is 10%.
Yeah, and the probability isn't so clear on the ROC chart, right? I think that's one of the things why I find it sometimes a little difficult to get my head around, because the thing that you're varying isn't actually explicitly on the chart.
Yeah, you cannot see it in two dimensions, how it is moving and how quickly it is moving to the left or to the right. So yeah, it's
Hey, quickly, Tomasz, before you finish up, you're focusing here on binary classification, right? Are these still useful when you have many classes?
Yes, so that's true that you can construct lift chart, and it will be a bit more tricky for our C curve, but you can construct this for every category, because of course you can do the same thing from the beginning, like you will sort it to according to different probability, not probability of bad, but probability of good, and then you will have this lift chart. So I'm typically looking at all these lift charts if they make sense, if there is not something really strange. But afterwards you are typically deciding according to category which you have in mind, which is most important for you. Like in this use cases, you want to find the bad ones, you are not interested in the good ones, for example.
Right. And as you say, you may have limited resources. So hey, we just got a couple of minutes left. Any quick conclusions, and maybe we'll see if there are any questions for those who want to stay.
Sorry. So yeah, so I only, let's say, I mentioned most of these, but according, like, I think these charts all can be used, and it's very good to show or compare the models based on these, and they are like overall measure of performance. So it's not only some snapshot, which is advantage, I would say. And the ROC curve and gains chart, in fact, it's very almost the same, but only different measures are drawn on x-axis. And maybe my opinion is that confusion matrix is not optimal to compare the models. Maybe it's good to measure how good is the model when you choose the right cut or the final cutoff, but not for deciding which model is better.
Great, thanks so much, Tomasz. That blog that you mentioned on the bottom there, didn't you say to me earlier, it's like one of our most popular articles, right?
Yeah, it is, and simply I written it because exactly the motivation at the beginning. I was not clear how they are connected together, so I wrote it down, and I'm using it from time to time.
Hey, great. We're just about at the half hour. Let's briefly announce next time's session, and anybody who wants to stick around and ask questions, there's the little Q&A button on the bottom of the screen. You can enter them there. So if you want to stick around, you're welcome to. We'll answer a couple of questions. as they come in. Next month, we're going to be talking about how do you select which is the right method of variable selection to use. So, you know, Thomas briefly mentioned this actually. If you want to have a model that's maybe for performance reasons or just for efficiency or for explainability, you want to have the fewest number of variables. You want to get rid of any sort of collinearity that exists in your variables. What methods can you use to winnow down your variables? So that's a big topic. We're going to see if we can cram it into half an hour at the next Dr. Data Science session. Nina, do we have any questions?
Yeah, Stephen. So we have like 3 questions. So are there other things besides this charge that you should use to evaluate the models?
That's interesting. So besides the sort of the raw stats and charts, yeah, Tomasz?
Like there are also it's not, sorry, it's not the full list, these charts. You can, if you want something simpler than chart, you can, based on ROC curve, it's for example area under curve measure, which is one value which is like summarizing how the ROC curve is good. But it's true that not always these are the best ones, so you also need to look sometimes at the model behavior, like if it makes sense, and be a bit suspicious when the model is too good, for example. But
yeah, also looking at coefficients, I think something you said that just reminded me of that. When you're looking at the sort of, is the model suspicious, right? I mean, if you look at the coefficients of variables and the size of those, the relative size or the sign of them,
yeah,
needs to make sense as well.
yeah, unfortunately it's not a general answer to this. There will be a lot of things or a lot of problems which can appear, and each of them will be addressed a bit differently, I suppose.
Yeah.
Cool. So our next question is probably everyone should have faced in their life once. How can I get an internship in data science if I don't have any experience in my past work?
Yeah, that is a very common question that I get asked, and I think well, I'll go back to the last point, the last bullet on my slide, which was about, you know, making up your own projects, right? I mean, often when I'm interviewing for internships, I feel a little bit unfair asking, well, have you got any experience? Because the whole point of an internship is to get some experience. So what I look for is whether they've worked on projects outside of the regular projects that you've worked on at school, right? So there are, of course, all the standard projects that you have as part of your coursework, but I ask, you know, have you done data science projects outside of your coursework? And there are so many interesting data sets out there. You can go onto Kaggle, the UC Irvine data sets. Google has just launched its own data set search capabilities. So there are lots of ways that you can find data sets that are interesting to you personally and just download them, ask some interesting questions, and, you know, use Python or whatever tool you like to analyze it and see if you can answer your questions. That's what I'd recommend.
Cool. That is great advice. And probably last one. What sort of questions do they normally ask in this data science interviews?
Tomasz, do you have a favorite interview question you ask when you're interviewing data science? Maybe you should give it away.
Not sure, not sure. But I think it's also like, everybody, you mentioned that, like, what was your interesting data science project, or what do you like about this? But
yeah, certainly I will always ask, right? Just describe a project in detail, and I'll be interested to see when your knowledge sort of bottoms out into the technical aspects. I actually often ask, what is an ROC chart? I also have some basic questions about how you sort of interpret the quality of models. So today's session is quite relevant for that. But
yeah, I know that like in the past, like if you ask, let's say, or I found out one person who does not understand these charts, because let's say he showed me the lift chart for a different category that I was interested in, and he was not aware that we have two categories, like two lift charts, two different lift charts. So it's also a bit, yeah, but this is for this topic, but yeah.
But anyway, I would say, I would repeat what Tomasz said, be prepared to talk about a project that you've worked on. And again, if you haven't worked on one, go out and find one. There's plenty of stuff to investigate. All right, thanks, Ninad.
Exactly. And that's it, folks, for this month. Stay safe, everyone. And we have amazing new topic for next month. So hope to see everyone up here on our next Dr. Data Science session in May. Thank you.